Maven Architecture. Here you can see the architectural diagram of Maven. Maven is a built automation tool used primarily for Java projects. Maven can also be used to build and manage projects written in C#, Ruby, Scala, and other languages. The Maven project is hosted by Apache Software Foundation, where it was formerly part of Jakarta project. Here you can see Maven 1x architecture. Here with here basically it is possible to establish parallel Maven builds, one using with old M1 settings and second one with M2 new one. The Maven 2 configuration file names and users have been modified, so the two builds should not conflict. With Maven 1.x X build is configured with the following files: project.xml, project object model pom definition, maven.xml custom build scripts, and project.properties general build settings, build.properties local build settings. In Maven 2 build is configured with the different file set pom.xml, pom for definition, and settings.xml local configuration. With regarding migration, the project object model pom has moved from project.xml file to pom.xml. XML schema has also changed from version 3 to version 4. New pom is normally superset of the old, so the first step in creating pom.xml is to copy over the project.xml. Then start tweaking. There are several new elements that can be added to the pom, but all are optional, so should not cause a problem with initial build. If you want some help converting your project.xml to a pom.xml, you can use Maven -1 plugin. If you run the following command, it will convert your project.xml into pom.xml. The command is men space 1:convert build.properties and build.properties and project.properties. These files have been replaced with settings.xml. Like with the pom, you can establish a parallel build environment. So the M1 build never breaks while the M2 build is being debugged. Additional local build customizing options can also be created using profiles. So how do I write custom script without maven.xml file? Everything in M2 is a plugin, so for doing any sort of custom work like that, you will need to make plugin. Greatly reduces the complexity with M2 because we only deal with proper plugins. The maven.xml file in M1 was a pseudo plugin essentially and greatly complicated the initial and 2. It promotes sharing of your work right from the get-go. To start with, you will probably write a plugin that is only applicable to your specific requirement or your team's work, but you will see people asking for some functionality and you will go, hey, I have something like that. And hopefully people who have concrete solutions will generalize their solutions so they can be shared with others. That's what we are trying to encourage here. And we establish that there's a lot of work built upon in projects Maven.xml that is not being shared, and we would like to try to change that. We plan to make a dead simple share plugin, so hopefully people can use their other projects plugins as a start for a plugin that they need themselves. That's the whole idea of Maven.xml to be removed. With directory structure, the POM allows customization of a directory structure in both Maven 1 and Maven 2 using the build tag. For simplicity, it would be ideal to move source from the Maven 2 default structure, but it is not required. You can begin by customizing the directories in Maven 2, and when satisfied that both build paths are working, move to the Maven 2 structure and customize the settings in Maven 1. With plugins, migrating plugins, the main conceptual change in plugins and their use has to do with the concept of a build lifecycle in Maven 2. Instead of using pre-goal and post-goal tags in Maven.xml to tie plugins goals into build process, the goals of the plugins are associated with the predefined stages of the build cycle. And with migrating repositories, every 4 hours, the Maven 1 X repositories is converted over to a Maven 2.x repository, and they were planning to release a plugin based on conversion tool, but currently. And here you can see the build system. The top part consists project.xml and maven.xml. The bottom you can see the Maven, and build system is build system interacts with local repository and remote repository. HTTP is connected back and forth during the interaction between build system and remote repository. Build system is connected to site here. Here you can see Maven plugin architecture. Maven can be considered as a plugin execution framework in which each and every task is conducted through plugins. Maven plugins are used to perform following type of task: jar file creation, war file creation, compilation of code files, unit testing, project documentation creation, project report creation. A plugin in Maven generally delivers a set of goals that can be performed by using this syntax. It is a MVN space and plugin name colon goal name. As an example, we can compile a Maven project with the Maven compiler plugin just by initializing a compile goal after execution. This command MVN space compile colon compile. Here you can see Maven 3.0.5 here, and inside it you can see the basic shell. Inside it you can see command line input parser, class path parser, class path manager, pom parser, Maven plugin downloader, and Maven 3.5 is connected to Maven central Maven repo in this diagram. And here Maven 3.0.5 is connected to local M2 repo. Here these two reports are connected to. Now we are focusing on build system. Maven builds a project using its project object model POM and a set of plugins. Here you can see an overview of Maven build elements. Here the gray colored rectangles are provided by you, and green colored rectangles green colored rectangles are provided by Maven, and the pink colored rectangle shaded is the output, the deployment artifacts from your project. These custom plugins are optional. The rest of the inputs are mandatory. And here you can see project object model pom.xml and repository, local or remote, are connected to Maven build system. Maven plugins are connected to Maven build system. Custom plugins are connected to Maven build system. Maven build system is connected to project artifacts, and this is output. As an example, we can consider this. Here is an overview of the top elements under settings. The settings element in the settings .xml file contains elements used to define values which configure Maven execution in various ways, like pom.xml, but should not be bundled to any specific project or distributed to an audience. These include values such as local repository location, alternative remote repository servers, and authentication information. So this is in settings.xml file. Now we are considering simple values. Half of the top level settings settings elements are simple values representing a range of values which describe elements of the build system that are active full time. Here local repository, this value is the path of this build system local repository. The default value is $use open braces user.home closing brace /m2 / repository. This element is especially useful for a main build server, allowing all logged in users to build from a common local repository. Interactive mode, true if Maven should attempt to interact with the user for input, false if not. Default is default to true. Offline, true if this build system should operate in offline mode, default to false. This element is useful for build servers which cannot connect to a remote repository, either because of network setup or security reasons. As an example 3, we can consider this. Invalid repository exception. Class invalid repository exception signals an error when adding a repository to the model resolver. This is in package org.apache.maven.model.resolution. As an example, we can consider this one. Actually, this is a warning. Some problems were encountered while building an effective settings. Unrecognized tag, build, position, start tag, start underscore tag seen in activation, etc. and build at /home/guest/.m2/settings.xml, line 16, column 13. This is occurred during the command mun clean install. Now we are focusing on pom.xml. A project model or POM is the fundamental unit of work in Maven. It is an XML file that contains information about the project and configuration details used by Maven to build the project. It contains default values for most projects. Examples for this is the build directory, which is a target, source directory, which is src/main/java, the test source directory, which is src/test.test/java, and so on. When executing a task or goal, Maven looks for the POM in the current directory. It reads the POM, gets the needed configuration information, then executes the goal. Here you can see POM overview. Here the asterisk element with asterisk element may be overridden, at least mostly, by profile element settings. And elements with here elements with double asterisk profile elements are the asterisk dash suffixed elements. Here this sign contains elements for meant inheritance. Maven projects dependencies builds artifacts. All of these are objects to be modeled and described. These objects are described by an XML file called a project object model. The POM tells Maven what sort of project it is dealing with and how to modify default behavior to generate output from source. In the same way, a Java web application has a web.xml that describes, configures, and customizes the application. A Maven project is defined by presence of pom.xml. It is a descriptive declaration of a project Maven. It is the figurative map that Maven needs to understand what it is looking at when it builds your project. You can also think of pom.xml as an analogous to a makefile or an ant build.xml. When you are using GNU make to build, something like MySQL, you will usually have a file named makefile that contains explicit instruction for building a binary from source. When you are using Apache Ant, you likely have the file named build.xml that contains explicit instruction for cleaning, compiling, packaging, and deploying an application. Make, Ant, and Maven are similar in that they rely on presence of a commonly named file such as makefile, build.xml, or pom.xml, but that is where the similarities end. If you look at Maven pom.xml, the majority of POM is going to deal with descriptions. Where is the source code? Where are the resources? What is the packaging? If you look at an ant build.xml file, you will see something entirely different. You will see explicit instructions for tasks such as compiling a set of Java classes. The Maven POM is declarative, and although you can certainly choose to include some procedural customizations via the Maven Ant plugin, for the most part you will not need to get into gritty procedural details of the build if your project's built. POM is also not specific to building Java projects. While most of the while Maven default plugins are targeted at building jar artifacts from a set of source, test, and resources, there's nothing preventing you from defining a POM for a project that contains C# resources and produces some proprietary Microsoft binary using Microsoft tools. We have established that the POM describes and declares it is unlike an ant or make in that it doesn't provide explicit instructions, and we have noted that POM concepts are not specific to Java. Here you can see the project object model and overview. POM contains 4 categories of description and configuration. The general project information. This includes a project name, the URL for a project, sponsoring organization, a list of developers and contributors, along with your project, along with your contributors, along with the license for a project. In build settings, in this section we customize the behavior of the default Maven build. We can change the location of sources and sets and tests. We can add new plugins. We can attach plugins goals to the lifecycle, and we can customize the site generating parameters. Build environment. The built environment consists of profiles that can be activated for use in different environments. For example, during development, you may want to deploy to a development server, whereas in production you want to deploy to a production server. The built environment customizes the built settings for specific environments. And is often supplemented by custom settings.xml in title/.m2. And POM relationships. A project rarely stand alone. It depends on other projects, inherits POM settings from parent projects, defines its own coordinates, and may include submodules. And if we reconsider this, POM stands for Project Object Model. It is an XML representation of a Maven project held in a file named pom.xml. When in the presence of Maven folks, speaking of a project is speaking the philosophical sense beyond a mere collection of files containing code. A project contains configurable files as well as the developers involved and roles that they play, and the defect tracking system, the organization and licenses, the URL of where project lives, the project dependencies, and all of other little pieces that come into play to give code life. It is a one-stop shop for all things concerning the project. In fact, in Maven world, a project does not need to contain any code at all, merely a pom.xml. The POM contains all necessary information about the project as well as configurations of plugins to be used during the build process. It is declarative manifestation of who, what, and where, while build cycle is the when and how. That is not to say that POM cannot affect the flow of this life cycle. It can. For example, by configuring Maven-Antran-plugin, one can embed Apache and task inside the POM. It is merely a declaration, however, whereas a build.xml tells and precisely what to do when it is run procedural. The POM states its configuration declarative. This the external force causes the lifecycle to skip the ant plugin execution. It does not stop the plugin that are executed from doing their magic. This is unlike a build.xml file, whereas tasks are almost always dependent on the lines executed before. Here, Maven coordinates. The POM defined above is the bare minimum. Here group ID artifact ID version group ID artifact ID version are group ID artifact ID version are all required fields. All the group ID and version do not need to be explicitly defined if they are inherited from a parent. These three fields act much like an address and timestamp in one. This makes a project place in a repository act like a coordinate system for Maven projects. Project ID, this is generally unique amongst an organization or a project. For example, all core Maven artifact do well should live under the group ID org.apache.maven. Group IDs do not necessarily use the dot notation. For example, the JUnit project. Note that the --noted group ID does not have to correspond to package structure that the project contains. It is, however, a good practice to follow. When stored within a repository, the group acts much like the Java packaging structure does in an operating system. The dots are replaced by OS-specific directory separators such as / in Unix, which becomes a relative directory structure from the base repository. Artifact ID. The artifact ID is generally the name that the project is known by. Although the group ID is important, people within the group will rarely mention the group ID in discussion. It along with the group ID creates a key that separates this project from every other project in the world. At least it should. Along with the group ID, the artifact ID fully defines the artifact's living quarters within the repository. As an example, my dash project lives in $m2_repo/org/code/host/mojo/my project. Version. This is the last piece of the naming puzzle. Group ID : artifact ID denotes a single project. But they cannot delineate which incarnation of the project that we are talking about. Do we want JUnit : JUnit of 2008 version 4.12 or of 2007 version 3.8.2? In short, code changes. Those changes should be versioned. In this element keeps those versions in line. It is also used within an artifact repository to separate versions from each other. For example, my dash project version 1.0 files live in the directory structure $m2_repo/org/codehost/mojo/my project/1.0. These three elements given here to a specific version of the project here, letting Maven know who we are dealing with and when it's in its software life cycle we want them. With regarding packaging, now that we have our address structure of group ID : artifact ID : version, there is one more standard label to give us a really complete what, that is project packaging. For example, pom.org.codehost.mojo:my project : 1.0 define can be packaged as a jar. We could make it into WAR by declaring a different packaging. When no packaging is declared, Maven assumes the packaging is default jar. POM relationships, the most powerful aspect of Maven is its handling of project relationships. This include dependencies and transitive dependencies, inheritance, and aggregation. Multi-module projects. Dependency management has a long tradition of being a complicated mesh for anything but the most trivial of project. Jamageddon quickly ensures as a dependency tree become a large and complicated. Jahel follows where versions of dependencies on one system are not equivalent to the versions developed it either by wrong version given or conflicting versions between similarly named jars. Maven solves both problems through a common local repository from which to link projects correctly, versions and all. Dependencies. The cornerstone of POM is its dependency list. Most projects depends on others to build and run correctly. If Maven does for you, this is if all Maven does for you is manage this list, you will gain a lot. Maven download and links the dependencies on compilation as well as on other goals that require them. As an added bonus, Maven brings in the dependencies of all those dependencies, transitive dependencies, allowing your list to focus solely on dependencies that your project requires. One of inheritance, one powerful addition that Maven brings to build management is concept of project inheritance. Although in build systems such as Ant, inheritance can be simulated, Maven makes project inheritance explicit in the project object model. And the super POM, POM, similar to inheritance of the objects in object-oriented programming, POMs that extend parents POM inherits certain values from the that parent. Moreover, just as Java objects ultimately inherits from java.lang.object, all project object models inherits from a base super POM. Dependency management. Beside inheriting certain top-level elements, parents have elements to configure values for child POMs and transitive dependencies. One of these elements is dependency management. It is used by POMs to help manage dependency information across all of its children. If my-parent project uses dependency management to define a dependency on JUnit: 4.12, then POMs inheriting from this one can set their dependency giving the group ID equal JUnit and artifact ID equal JUnit only, and Maven will fill the version set by the parent. The benefit of this method are obvious. Dependency details can be set in one central location which propagate to all inheriting POMs. Aggregation or multi-module. A project with modules known as a multi-module or aggregator project. Modules are projects that this POM lists and executed as a group. A POM package projects may aggregate the build of a set of projects by listing them as modules, which are relative path to directories or POM files of those projects. Properties are the last required piece to understand POM basics. Maven properties are value placeholders like properties in Ant. Their values are accessible anywhere within a POM by using the notation $, open curly brace, close curly brace where X is the property, or they can be used by plugins as default values. And in this diagram you can see properties here. Build settings beyond the basics of POM given before. Given here, there are two more elements that must understood before claiming basic competency of the POM. They are built element that handles things like declaring your project's directory structure and managing plugins, and reporting elements that largely mirrors the built element for reporting purposes. The built, according to the POM 4.0.0 XSD, the built element is conceptually divided into two parts. There is a base build type, which contains the set of elements common to both built elements, the top level built element and the project, and the built element and the profiles covered profiles. There's a build type which contains base build set as well as more elements for the top level definition. The basic built element set. Base build is exactly as it sounds, the base set of elements between the two built element in the POM. Resources, another set of built element, is specifying where resources exist within your project. Resources are not usually code. They are not compiled, but are items meant to be bundled within your project or used for various other reasons such as code generation. Plugins, beyond the standard coordinate of group ID : artifact ID : version, there are elements which configure the plugins or this build interaction with. Plugin management is an element that is seen along side plugins. Plugin management contains plugin element in which the same way, except that rather than configuring plugin information for this particular project build, it is intended to configure project builds that inherit from this one. However, this only configured plugins that are actually referred within the plugin element in the children or the current POM. The children have every right to override plugin management element definitions. The build element set, the build type in the XSD denotes denotes those elements that are available for the project build. Despite the number of extra elements, 6, there are really only two groups of elements that project build contains that are missing from the project from the profile build: directories and extensions. Directories, the set of directory element live within the parent built element, which set various directory structures for the POM as a whole. Since they do not exist in profile build, these cannot be altered by profiles. Extensions are a list of artifacts that are to be used in this build. They will be included in the running build class path. They can enable extensions to build process, such as add an FTP provider for the wagon transport mechanisms, as well as make plugins active which make changes to the build lifecycle. In short, extensions are artifacts that are activated during build. The extensions do not have to actually do anything for contain mojo. For this reason, extensions are excellent for specifying one out of multiple implementation of common plugin interface. Reporting. Reporting contains the elements that correspond especially for the site generation phase. Certain Maven plugins generate reports defined and configured under report element. For example, generating Java doc reports. Much like the built element's ability to configure plugins, reporting commands the same ability. The glaring difference is that rather than fine-grained control of plugin goals within the executions block, reporting configures goals within report set elements. And subtler difference is that a plugin configuration under the reporting element works as a built plugin configuration. Although the opposite is not true, a built plugin configuration does not affect a report plugin. Report sets. It is important to keep in mind that an individual plugin may have multiple goals. Each goal may have separate configuration. Report sets configure execution of a report plugins goals that does this familiar deja vu. The same thing was said about built execution element with one difference. You cannot bind a report to another page. Sorry. Here you can see more project information. Several elements do not affect the build, but rather document the project for the convenience of developers. Many of these elements are used to fill in project details when generating the project's website. However, like all POM declarations, plugins can use them for anything. Followings are the simplest element: name, description, URL, inception here. Name. Projects tend to have conventional names beyond the artifact ID. The Sun engineers did not refer to their project as Java-1.5, but rather just called it Tiger. Here is where to set that value. Description, a short human readable description of the project. Although this should not replace formal documentation, a quick comment to any readers of the POM is always helpful. URL, the project's homepage. Inception year, the year the project was first created. Licenses are legal documents defining how and when a project or parts of a project may be used. A project should list licenses that apply directly to this project and not list licenses that apply to the project's dependencies. Organization. The most projects are run by some sort of organization, business, private group, etc. Here is where the most basic information is set. Developers. All projects consist of files that were created at some time by a person. Like other systems that surround a project, so to do this, people involved with a project have a stake in the project. Developers are presumably members of the project's core development. Note that although an organization may have many programmers as members, it is not good form to list them all as developers, but only those who are immediately responsible for the code. A good rule of thumb is if the person should not contacted about the project, they do not need to be listed here. Contributors are like developers, yet play an auxiliary role in a project's lifecycle. Perhaps the contributor sent in a bug fix or added some important information. A healthy open source project will like to have more contributors than developers. In the environment settings, in the issue management, this define the defect tracking system, Bugzilla, TestTrack, ClearQuest, etc. used. Although there is nothing stopping a plugin from using this information for something, it's primarily used for generating project documentation. Continuous integration management. Continuous integration build system based upon triggers and timings such as hourly or daily have grown in favor over manual builds in the past few years. As build systems have become more standardized, so have the systems that run the trigger those builds. Although the majority of configuration is up to the specific program used, continuum, cruise control, etc., there are a few configurations which may take place within the POM. Maven has captured a few of recurring settings within a set of notifier elements. A notifier is a manner in which people are notified of a certain build status. Mailing lists. Mailing lists are a great tool for keeping in touch with people about project. Most mailing lists are for developers and users. SCM, the software configuration management, so-called the source code control management or succinctly version control, is an integral part of any healthy project. If your Maven project uses a SCM system, it does, doesn't it? Then here is where you place that information into POM. Prerequisites. POM may have certain prerequisites in order to execute correctly. The only element that exists as prerequisite in POM 4.0.0 is the Maven element, which takes a minimum version number. Repositories. Repositories are collection of artifacts which adhere to Maven repository directory layout. In order to be a Maven repository artifact, the POM file must live within the structure $base _ repo / group ID / artifact ID / version / artifact ID -version.pom. $base _ repo can be local file structure or remote base URL. The remaining layout will be same. Repositories exist as a place to collect and store artifact. Whenever a project has a dependency upon an artifact, Maven will first attempt to use a local copy of the specified artifact. If that artifact does not exist in the local repository, it will then attempt to download from the remote repository. The repository element within a POM is specify those alternate repositories to search. Plugin repositories are home to two major types of artifact. The first are artifacts that are used as dependencies of other artifacts. These are the majority of artifacts that reside within central. The other type of artifacts is plugins. Maven plugins are themselves a special type of artifacts. Because of this, plugin repositories may be separated from other repositories, although I have yet to hear a convincing argument for doing so. In any case, the structure of plugin repositories element block is similar to the repositories element. The plugin repository element each specify a remote location where Maven can find new plugins. Distribution management. Distribution management act precisely as it sounds. It manages the distribution of the artifact and supporting file generated throughout the build process, starting with the last element first. Repository. Whereas the repositories element is specified in the POM the location and manner in which Maven may download remote artifact for use by current project. Distribution management specifies where and how this project will get a remote repository when it is deployed. Repository element will be used as for snapshot distribution if the snapshot repository is not defined. Site distribution. More than distribution to the repository, distribution management is responsible for defining how to deploy the project site and documentation. And relocation projects are not static; they are living things. A common thing that happen as project grow is that they are focused to move more suitable quarters. For example, when your next widely successful open source project moves under the Apache umbrella, it would be good to give users a heads up that the project is being renamed to org.apache.my-project:1.0. Besides specifying new address, it is good form to provide message explaining why. Profiles. A new feature of POM 4.0 is the ability of a project to change settings depending on the environment where it is being built. A profile element contains both an optional activation, a profile trigger, and a set of changes to be made to the POM. If that profile has been activated, for example, a project built for test environment may point to a different database than that of the final deployment, or dependencies may be pulled from different repositories based upon JDK version used. The element of profiles are there. Activations are the key of the profile. Power of profile comes from its ability to modify the basic POM only under certain circumstances. Those circumstances are specified via an activating element. The base built element set, if we revisited, the reasons for two types of built element reside in fact that that does not make sense for a profile to configure built directories and extension as it does in the top level of a POM. Regardless of in which environment the project is built, some values will remain constant, such as directory structure of a source code. If you find your project needing to keep two sets of code for different environments, it may be prudent to investigate refactoring project into two or more separate projects. Here you can see POM, and you can see POM relationships. Under that you can see coordinates. Under that you can see group ID, artifact ID, and version. You can see on aggregation, and you can see modules under that, and you can see inheritance under POM relationships. Here you can see parents, dependency management, and under dependencies you can see dependency management and dependencies. Here you can see project information under POM, and you can see name, description, URL, inception year, licenses, developers, contributors, and organization under project information. Here you can see build system under POM, and you can see properties, packaging, build, and reporting under build system. Here you can see build environment under POM, and you can see environment information, Maven, and Maven environment under build environment. You can see issue management, CI management, mailing list, and SCM under environment information. And you can see prerequest, repositories, distribution management, profiles under Maven environment. And you can see repositories, plugin repositories, and repositories and plugin repositories under repositories. And you can see profile under profiles, and activation and suffix elements under profile. Here you can see element may be overridden at least mostly by profile element settings. Here modules, dependency management, build, reporting, repositories, plugin repositories, distribution management, and profile elements that are the asterisk dash suffix element here under profile. These are the element contains element meant for inheritance. Here you can see dependency management and build. Here you can see the super pom is always the base parent. The super pom, all Maven projects POMs extend the super POM, which defines a set of defaults shared by all projects. The super pom is a part of Maven installation. Depending on the Maven version, it can be found in the maven-x.y.z- etc.jar or maven-model-builder.xy.z.jar file in $ open curly brace m2 underscore home close curly brace /lib. If you look in this jar file, you will find a file named pom-4.0.0.xml under the org.apache.maven.model package. It is also published on the Maven reference site that is available on each version of Maven separately, and for example Maven 3.1.1, it can be found on the Maven model builder documentation. Here you can see inherit from. So com.company.killerapp-stores 1.0-snapshot is inherit from here, and com.mycompany-killer-app-api 1.0-snapshot and com.mycompany-killer-app-model 1.0-snapshot are inherit from these three inherit from com.mycompany-killer-app 1.0-snapshot, and this is this inherits from superpom here. Now as an example, we can consider the minimum requirement for a POM are following. The minimum requirement for a POM are following here: project, root, model version should be at least should be set to 4.0.0 this version, and group ID, the ID of the project's group, artifact ID, the ID of the artifact project, the ID of the artifact project, version, the version of the artifact under the specified group. The POM requires that it's a group ID, artifact ID, and version be configured. These are three values from project's fully qualified artifact name. This is in the form of group ID colon artifact ID colon version. As an example, we can consider here com.mycompany.app colon my-app colon 1. Also, if configuration details are not specified, Maven will use their defaults. One of these default values is the package type. Every Maven package every Maven project has a package type. If it is not specified in the pom, then the default value jar would be used. Furthermore, you can see that in the minimal pom here, the repositories are not specified. If you build your project using the minimal pom here, it would inherit the repository's configuration in the super pom. Therefore, when Maven uses the dependencies in this minimal pom, it would know that these dependencies will be downloaded from https repo.maven.apache.org/maven2, which has specified in the super pom. As an example 2, we can consider this one, the plugins. Here, beyond the standard coordinate of group ID artifact ID version, there are elements which configure the plugin or these builds interact with extensions, true or false, whether or not to load extensions of this plugins. It is by default false. Extensions are inherited, true or false, whether or not this plugin configuration should apply POMs which inherit from this one. Default is true. Configuration, this is specific to individual plugin. Without going too in depth into the mechanics of how plugin works, suffix it to say that whatever properties that the plugin mojo may expect, these are getters and setters in the Java mojo bin, for example, can be specified here. In this example, we are setting the classifier property to test maven jar.plugin in mojo. It may be good to note that all configuration elements, wherever they are within POM, are intended to pass values to another underlying system, such as a plugin. In other words, values within configurations element are never explicitly required by the POM schema, but the plugin goal has every right to require configuration values. Dependencies are seen a lot within POM and are an element under all plugin element blocks. Dependencies have the same structure and function as under the base build. The major difference in this case is that instead of applying as dependencies of the project, they now apply as dependencies of the plugin that they are under. The power of this is to alter the dependency list of a plugin, perhaps removing an unused runtime dependency via exclusions, or by altering the version of a required dependency. Executions. It is important to keep in mind that the plugin may have multiple goals. Each goal may have a separate configuration, possibly even building a plugin goal to a different pace together. Executions configure the execution of a plugin goals. For example, suppose you wanted to bind the /run goal to the verify pace. We want the task to echo the build directory as well as avoid passing on this configuration to its configuration, assuming it is a parent by setting inherited or false. As an error example, we can consider this one occurred in the environment with pipeline of a Java project and Git repository. Not found Maven pom file. Error unhandled. Not found. Maven pom pom file /home /vsds /work/1/s /pom.xml. Finishing Maven pom.xml. Now we are focusing on Maven. Here you can see Apache Maven internal design architecture. This is Maven 4.x. Apache Maven is a project development, management and comprehension tool based on the concept of a project object model, builds, dependency management, documentation creation, site publication and distribution publication are all controlled from the pom.xml declarative file. Apache Maven can be extended by plugins to utilize number of other development tools for reporting and build process. Here is a diagram that shows the internal design architecture of Apache Maven. Apache Maven modules are labeled in this colored boxes, and third-party modules are labeled in uncolored boxes here, and this one also. Here you can see a distribution. Distribution is connected to SLF4J-provider, SLA, and it is connected to SLF4J-wrapper, and also distribution is connected to embedder, and you can see here BOM, and embedder is connected to SL4J-wrapper and also connected to compact, and compact is connected to core, and core is connected to plugin -mp API, and core is connected to toolchain builder and settings builder and resolver provider. Toolchain builder is connected to toolchain model, and settings provider is connected to settings builder support, and and model builder is connected to builder support, and also connected to model transform and model and artifact. And here resolver provider is connected to repository metadata, and you can see here embedder is connected to commons CLI, and SL4J-wrapper is connected to SL4J API, and core is connected to shared utils, and shared utils is connected to Jansi, and plugin API is connected to Sisu, and inside it you can see a plugin API is connected to Perplex, and in Sisu you can see Plexus and Inject. Plexus is connected to Inject is connected to Juice, and Plexus is connected to class worlds, and inside the Plexus you can see class worlds, interpolation, sec dispatcher, Cyper and utils, toolchain builder, settings builder and model builder are connected to interpolation. Settings builder is connected to sec dispatcher, and resolver provider is connected to IMPL. Inside the resolver you can see IMPL, SPI, API and util. IMPL is connected to SPI and util. SPI is connected to API and util is connected to API. Here you can see a standard Maven directory layout. Having a common directory layout allows users familiar with one Maven project to immediately feel at home in another Maven project. The advantages are analogous to adopting a site-wide look and feel. Try to conform to this structure as much as possible. However, if you can't, these settings can be overridden via the project descriptor. Here you can see source main Java application and library sources. Here you can see source main resources. This is application library or library resources. Here you can see source main filters, resource filter files, and you can see source main web application sources. And here you can see source test Java test resource or test sources, source test resources, test resources, and source test filters, test resource filter files. Here you can see source IT integration test, primarily for plugins, source assembly descriptors, source site, and you can see and top level you can see you can find license.txt project license, notice.txt notices and attributions required by library and that the project depends on, readme.txt projects readme. At the top level, files descriptive of the project, a pom.xml file. Basically at the top level, the file descriptive of the project, a pom.xml file. In addition, there are textual documents meant for the user to be able to read immediately on receiving the source. Readme.txt, license.txt, etc. There are two subdirectories of the structure, src and target. The only other directories would be expected here are metadata like cvs.git or .svn and any subprojects in multi-project build, each of which would be laid out as here. As previous directories for metadata. The target directory is used to house all output of the build. The src directory contains all of the source material for building the project, its site, project, its site, and so on. It contains a subdirectory for each type. Main for the main build artifact, test for the unit test code and resources, site, and so on. within artifact producing source directories, main, that is main and test. For the main, there is one directory for the language Java, under which normal package hierarchy exists, and one for resources. The structure which is copied to the target class path given the default resource definition. If there are other contributing sources to the artifact build, they would be under other subdirectories. For example, source main ANTLR would contain ANTLR grammar definition files. Here you can see a directory layout, project folder, then source and target. Then it's under source there are main, test, IT, and assembly and site. Under main there are Java resources, a web app config, script, and filters here in this diagram. Under test, Java resources and filters here. Here you can see Maven life cycles and paces. Dark ones are the frequently used. Here you can see the all build paces of the default, clean, and site life cycles, which are executed in the order given up to the point of the one is specified. Here you can see clean life cycle, pre-clean, execute processes needed prior to the actual process cleaning. Clean pace, remove all files generated by the previous build. Post clean, execute processes needed to finalize the project cleaning. Here you can see default life cycle. Here you can see validate the project is correct and all necessary information is available. Here you can see the pace initialize build state. For example, set properties or create directories. Here you can see generate sources, generate any source code for inclusion in compilation. Paste process sources, process the source code, for example, to filter any values. Generate resources for inclusion in the package. Process resources, copy and process the resources into the destination directory ready for packaging. Compile the source code of the project. Paste here the process classes. Post process the generated files from compilation, for example, to do bytecode enhancement on Java classes. Generate test sources, generate any test source code for inclusion in compilation. Process test sources, process the test source code, for example, to filter any values. generate test resources, create resources for testing, process test resources, copy and process the resources into the test destination directory. Here you can see process test classes. So in this diagram, one process is missing. It's called test compile after test process test resources. In test compile the test source code into the test destination directory. Then process test classes. Process post process the generated text generated file from the test compilation. For example, to do bytecode enhancement on Java classes, the paste test, run test using a suitable unit testing framework. These tests should not require the code be packaged or deployed. Prepare package. Perform any operations necessary to prepare a package before the actual packaging. This is often result in an unpacked processed version of the package. Take the compile code and package it in its distributable format such as a jar. Pre-integration test. Perform actions required before integration tests are executed. This may involve things such as setting up the required environment. Integration test. Process and deploy the package if necessary into an environment where integration tests can be run. And there's another page called post integration test. It's not shown here. Perform actions required after integration tests have been executed. This may include cleaning up the environment. And then verify. Run any checks to verify the package is valid and meets quality criteria. Then install the package into the local repository for use as a dependency in other projects locally. Deploy done in an integration or release environment copies the final package to the remote repository for sharing with other developers and projects. Here site life cycle. The paces are here, and pre-site execute processes needed to execute processes needed prior to the actual project site generation. Generate the project site documentation here, site, and post site execute processes needed to finalize the site generation and to prepare for site deployment. Site deploy the generated site documentation to the specified web server, and here you can see the paces. So here you can see in clean lifecycle, pre-clean is connected to clean, and clean is connected to post-clean. In default lifecycle, validate is connected to initialize is connected to generate resources, and it is connected to process resources, and it is connected to generate source. Initialize is connected to generate sources. Generate sources is connected to process sources. generates and process sources is connected to generate resources. Generate resources is connected to process resources. Process resources is connected to compile. Compile is connected to process classes. Process classes is connected to generate test resources. Generate test resources is connected to process test resources. Process test resources is connected to generate test. Process classes is connected to generate test sources. Generate test sources is connected to process test sources. Process test sources is connected to generate test resources. Generate test resources is connected to process test resources. Process test resources is connected to test compile. It's not shown here. Test compile is connected to process test classes. Process test classes is connected to test. Test is connected to prepare package. Prepare package is connected to package. Package is connected to pre-integration test. Pre-integration test is connected to integration test. Integration test is connected to post-integration test, not shown here. And post-integration test is connected to verify. Verify is connected to install, and install is connected to deploy. In site lifecycle, pre-site is connected to site, and site is connected to post-site, and post-site is connected to site deploy. As an example, we can consider this one, Maven clean deploy. In a build environment, use the following this command to cleanly build and deploy artifact into the shared repository. Here the clean paste clean remove all files generated by the previous build, and in the paste deploy done in an integration or release environment, copies final package to the remote repository for sharing with other developers and projects. As an example 2, we can consider this one, Maven compile test compile. This is compile is plugin, and this is the goal, and this is called the paste test compile. This compile the test source code into the test destination directory. Here this is regarding packaging. The first and most common way is to set the packaging for your project via equally named POM element packaging. Some of the valid packaging values are Java, EAR, and POM. If no packaging value has been specified, it will default to jar. Each packaging contains a list of goals to bind up to a particular page. Here we are considering the default to jar. As an example 3, we can consider this one, configure plugins. The second way to add goals to pages is to configure plugins with your project. Plugins are artifacts that provide goals to Maven. Furthermore, a plugin may have one or more goals wherein each goal represents a capability of that plugin. For example, compiler plugin has two goals, compile and test compile. The former compile the source code of your main code, while the latter compiles the source code of your test code. Goals that are configured will be added to the goals already bound to the lifecycle from the packaging selected. If more than one goal is bound to a particular page, the order is used is those from the packaging are executed first, followed by those configured in the POM. Note that you can use executions element to gain more control over the order of particular goals. For example, here the Modello plugin binds by default its goal Modello Java to the generate sources pace. Note that the Modello Java goals generate Java source codes. So to use Modello plugin and have it generate sources from the model and incorporate that that into build, you would add the following this to your POM in the plugin section of build. You might be wondering why executions element is there. That is so that you can run the same goal multiple times with different configurations if needed. Separate executions can also be given an ID so that during inheritance or application phases during inheritance or the application of profiles, you can control whether goal configuration is merged or turned into an additional execution. When multiple executions are given that match a particular phase, they are executed in the order specified in the POM with inherited execution running first. As an example 4, we can consider this code segment related to profile activation. This is in file settings.xml. Profiles can be explicitly specified using stroke dash p command line flag. This flag is followed by a comma delimited list of profile IDs to use. Profiles specified in the option are activated in addition to any profiles which are activated by their activation configuration or the activation profiles section in settings.xml. From Maven 4 onward, Maven will refuse to activate or deactivate a profile that cannot be resolved. To prevent this, prefix the profile identifier with an question mark, making it as optional. Here you can see the command here. Profiles can be activated in the Maven settings via the activate profiles section. This section takes a list of active profile elements, each containing a profile ID inside. Profiles listed in active profiles tag would be activated by default every time a project uses it. Here there are two examples of POMs share a common dependency and each has non-trivial dependency. This information can be put in a parent POM like this. This is the parent POM, The dependency management section is a mechanism for centralizing dependency information. When you have a set of projects that inherits from a common parent, it is possible to put all information about the dependency in the common POM and have simpler references to the artifacts in the child POMs. So you can see here group ID A, and here excluding C, exclusion C, and here group ID C, and here group ID A. So this is the parent POM. As an exception example, we can consider this one occurred in environment with Sonar scanner for Maven. Here you can see scanning per project and etc. And here you can see Apache org.apache.maven.exception, default exception handler, get message here, and etc. As an error example, you can see here build failure and fail to execute goal org.apache.maven.plugins Maven archetype plugin 2.1 generate default CLI on project standalone POM directory. My app already exists. Please run from clean directory, etc. Here as an additional example, we can consider Maven OPTS, Maven underscore OPTS environment variable. This variable contains parameters used to start up JVM running Maven and can be used to supply additional options to it. For example, JVM memory settings could be defined with the value -xms 256m and -xms 512m. Now we are focusing on local repository. The local repository is a directory on the computer where Maven runs. It catches remote downloads and contains temporary built artifacts that you have not yet released. Here you can see the diagram. This is a diagram which shows the defined flow in which Maven to resolve the dependency. Here you can see the step 1 is read. Maven core read project dot here pom.xml. This is related to Maven 1.x, but in the new version from 2.x this will be pom.xml, and then it will build then Maven core will check if artifact is in local repository, and then get artifact from remote repository again, and back again get artifact from remote repository. then put downloaded artifact in local repository, and thereafter generate files. For example, create jar file here. Here in step 1, Maven core is connected to pom.xml, and Maven core in step 2 Maven core is connected to local repository, and step 3 Maven core is connected to remote repository, and HTTP is passed from during the interactions, and step 4 Maven core is connected to local repository. Here this is JVM1 and this is JVM2 is a web server here. As an example, we can consider Maven install. In the PES install, install the package into the local repository for use as a dependency in other projects locally. Here you can see local repository. This value is the path of this build system's local repository. The default value is $, user.home, then .m2, then repository. This element is especially useful for a main build server, allowing all logged in users to build from a common local repository. This is in settings.xml file. So in interactive mode, true if Maven should attempt to interact with user for input, false if not, default to true. Offline, if this build system should operate offline mode, default to false. This element is useful for build servers which cannot connect to a remote repository, either because of network setup or security reasons. As an example 3, we can consider this one, include custom library into Maven local repository. Here download the captcha extract, download the captcha, extract it, and copy the captcha dash $version jar to somewhere else, for example C drive, and run this command. Then captcha, the captcha jar is installed, copied into your local into our Maven local repository. As an example, we can exception example, we can consider this one. Here the local class local repository not accessible exception signals a failure to store files within a local repository, and this is in package org.apache.maven.repository. And here you can see could not create local repository at /test artifacts from /m2 repository. And as an error example, we can consider this failure to execute goal on project X, could not resolve dependencies for project X, failure to find Y in archive repository was cached in the local repository. Resolution will not be reattempted until the update interval of internal has elapsed or update are forced. Remote now we are focusing on remote repository. Remote repositories refer to any other type of repository accessed by a variety of protocols such as file :// and https://. These repositories might be a truly remote repository set up by a third party to provide their artifact for downloading. For example, repo.maven.apache.org. Other remote repositories may be internal repositories set up on a file or HTTP server within your company, used to share private artifacts between development terms and for releases. Here you can see this is a diagram which shows the defined flow in which Maven to resolve the dependency. Here you can see Maven read there should be a pom.xml and then build it. Then check, then Maven core check if artifact is in local repository. Then here the get artifact from remote repository and put download artifact in local repository, and then generate in the core generate files or create jar. So here Maven core is connected to pom.xml here. This is the older version, so in 1.x this is project XML. Here 1.2 and onward it will be pom.xml. Then in step 2 here Maven core is connected to local repository, and step 3 Maven core interact with remote repository to HTTP, and step 4 Maven core is connected to local repository, and this is in JVM1 and this is in JVM2 the web server. Here you can see Maven repository architecture. Maven follows a two repository model wherein it maintains a local repository which is created when you execute the first Maven command. It downloads the dependencies from the remote repository into this local repository and then builds projects. Architecture looks like here, and Maven project is compiled. It check the local repository for dependencies. If dependencies do not exist, Maven download them from the remote repository. Once dependencies are downloaded, they are installed once the dependencies are downloaded, they are installed in the local repository. Once all dependencies are met, Maven compile the code and the project. Here Maven project is connected to local repository. Default location $user.home/.m2/repository, and local repository connected to remote repository here, and Maven is connected to remote repository and local repository. Downloads is connected to, is passed from Maven to remote repository, and install is passed from Maven to local repository. Here you can see Maven central repository. This is for to use and contribute to Maven central repository. This include that need dependencies for their own build core project that wish to have their releases added to the Maven central repository. Even if they don't use Maven as their build tool, discontinue support for TLS version 1.1 and below as of June 15th of 2018, and discontinue support for HTTP as of June 15th 2020. Here you can see users. Maven is connected to local repository, plugin repository, and here Maven is connected to a local repository, and here Maven is connected to dependent public repositories. POM file is passed from Maven to independent public repositories. And this is repository and plugin repositories, and in independent public repositories include JBoss and others. And Maven is connected to central CDN, and central default is passed from Maven to central CDN, and Maven is connected to here mirrors and repository manager. Settings.xml is connected to passed through Maven to mirrors and repository manager, and mirror of command is here. A mirror of tag is there here, and repository manager is connected to private data and central repository and independent public repositories. Cache is passed from the central repository manager to central repository and independent public repositories. In central repository is here, and aggregation is passed passed to central data, and central data is connected to central CDN and mirrors. Publication is passed from central data to central CDN and mirrors, and here you can see central archetype catalog and central index. Inside mirrors you can see here iBiblio, Google, and rsync. Deprecated is passed from central repository to public project dedicated staging repositories. Here you can see XY and etc. And push is passed from public Forges multi-project staging repositories to central repository. You can see Apache, OSSRH, and etc. and public Forges multi-project staging repositories. Here this is the diagram which shows the defined flow in which Maven to resolve dependency. Here you can see the local repository. If dependency found, it will then retrieve dependency. It's connected to retrieve dependency, and local repository is if dependency not found, is connected to central repository, and if dependency is found in central repository, it is connected to retrieve dependency, and if dependency not found, central repository is connected went through remote repository defined, whether or not. And if it is defined, then it's connected to remote repository. If it is not, it's connected to unable to find dependency. And here also if dependency is not found in remote repository, is connected to unable to find repository, and remote repository, if dependency found, is connected to retrieve dependency. Here you can see Maven 2 repository layout. Maven 2 repository layout format is the default layout since Maven 2, superseding old Maven 1 layout, where here the group ID as directory is group ID with dot replaced by /. For example, org /maven apache.maven. Here $sign after artifact ID is the artifact ID. The version is the version with some additional possibilities on a snapshot. Extension is the file extension, for example zip or tar.gs. Classifier is the artifact classifier when available, and checksums is a list of checksums algorithm, MD5 and SHA-1 by default. Maven metadata.xml file format is defined in Maven repository metadata module. .asc file is optional, may be requested in some repository like center repository, and is PGB detach signature file. Obviously a group ID, artifact ID, and version are defined in pom.xml, but what about classifier and extension? How they defined? Classifier and extension definition is completely different at artifact publication and usage times. At artifact publication time, extension and classifier are defined by plugins that create the artifact and attach them for publication. Some plugins provide configuration parameters to be able to override default values. For example, Maven jar plugins jar::jar goal produces by default an artifact with jar extension and empty classifier. The classifier goal parameter can be used to define classifier. There is no parameter to override the extension. At artifact usage time, extension and classifier are defined by dependency type and classifier definition in pom.xml. Here type jar by default define an extension and classifier, and classifier is optional to override default classifier defined by dependency type. Using an internal repository, using the internal repository is quite simple. Simply make a change to add the repository's element. Your internal, if your internal repository requires authentication, the ID element can be used in your settings file to specify logging information. Here deploying third-party jars to remote repository as an example 2. to deploy third-party jar, use the deploy file goal under Maven deploy plugin. First, the Vagrant, for example, Vagrant provider, Vagrant FTP, Vagrant file, etc. must be placed to your $Maven, $open brace maven.home close brace /lib. Then execute this command here. As an example 3, we can consider this one: http://report.1 maven.org./maven2/. This is the default repository for central repository. If the site is not available, finally it can be redirected to http://search.maven.org. As an error example, we can consider this one occurred with the environment grail 2.5.x .x. An error occurred while processing Maven artifact task diagnosis. Error downloading Vagrant provider from remote repository missing org.apache.maven.vagrant.: Maven http://jar:1.0 beta 2 etc. Now we are focusing on site. The site plugin is used to generate a site for the project. The generated site also includes the project's reports that were configured in the POM. Here you can see a main website mechanisms overview. Here you can see the source SCM, https://gitbox.apache.org/repos./asf/maven-git https://github.com/apache/maven-git. And here you can see source edit, git box or git hub, main site source, git, maven site.git, and you can see this is local edit and it's connected to Maven main site, target /site. It's Maven site is MEN site is passed from local edit to Maven local main site, and here source edit is connected to site production. Jenkins https /build.apache.org/job/maven box/job/maven site / and Maven MEN site is passed from source edit to or main site source edit source git to site production svn. And here site production svn is connected to complete Maven site. svn nvpub sub is passed from site production svn to complete Maven site, and this is https ://maven.apache.org, and is equal Maven site content. Composition by symbolic links created with and from components link plus components documentation archive / latest plus versions plus current. The main site content component documentation is staging / xxx archives / yyyy latest. Component documentation / xxx archives / yyyy $version / xxx / yyyy and HTML SVN for SVN pub sub https / svn.apache.org / repos / asf / maven / website / content https / svn.apache.org / repos / asf / maven / website / components. Since December 2012, the overall website uses SVN pub sub mechanism, and main website uses Apache CMS. Here you can see Maven site plugin developer overview. Doxia to pass many markup languages, then render HTML. Doxia site tools, here site renderer to integrate documents, to integrate document content into template packaged as skin. Maven reporting executor to manage reports execution, since Maven 3 execution was managed by Maven itself in Maven 2. And here you can see Maven here, and shared components are here, and Doxia are this 1 2 3 4 6 and this was this one, and Doxia site tools are these are Doxia 5 site tools. Velocity is not a part of Doxia here. Here the Maven is connected to Maven plugin API. Maven is connected to Maven site plugin and report plugins, and it's go through Maven API, Maven plugin API, and when invoked directly as goal, when Maven is connected to report plugins here, and Maven site plugin is connected to markup passes, integration tool, and reporting API. Handwritten contents are passed from Maven site plugin to markup passes. Reporting exe is passed from Maven site plugin to reporting API, and report plugins contains reporting API and reporting IMPL, and report plugin is connected to Doxia sync API. Report content is passed from report plugins to Doxia sync API, Integration tool is connected to decoration model here. Dexia sync API is connected to Doxia module, and Doxia module has markup parser, and also basically Doxia sync API is connected to Doxia module markdown, Doxia module XHML, markup renderer, XML markup renderer module is there, and inside that markup parser is in Doxia module, and markdown markup parser equal flexmark equal HTML render is in Doxia module markdown. XML markup parser is in Doxia module XHTML. Here XML XHTML markup renderer is connected to site renderer. Site renderer is connected to velocity. Site renderer is interact with velocity, and velocity interact with skins, reusable templates, and it is connected to site output is equal contents plus template. Skins are connecting with skin module, and here velocity is not part of Doxis, or other white boxes are part of Doxia. And also this is markup pass is not part of Doxia. As an example, we can consider Maven site. This is to generate project site and reports. By default, the resulting site will be in the target /site / directory. Here you can consider deploying a site. To be able to deploy a site, you must first specify where the site will be deployed. This is set in the distribution management element of the POM shown here. The ID element defines the repository so that you can attach credential to it in your settings.html file using servers element as you would for any other repository. The URL gives the location to deploy to. In this example, we copy the host www.yourcompany.com using the path www/docs/project. Over SCP protocol, you can read more about which protocols with the documentation. If subprojects inherit the site URL from the parent POM, they will automatically append their artifact ID to form their effective deployment location. Now you can execute the site deploy goal from your project directory. Note, site must be generated first before executing site deploy. If you want to generate the site and deploy in it one go, you can utilize site dash deploy phase of the lifecycle. To do this, just execute Maven site dash deploy. Here we can, as an example 3, we can consider this example. This example shows how to configure the standard project info reports that display information from POM in a friendly format. Maven has several reports that you can add to your website to display the current state of the project. These reports take the form of plugin goals, just like those used to build the project. The Maven project info reports plugin provides many standard reports by extracting information from the POM For example, continuous integration, dependencies, issue tracking, license, mailing list, project team, source repository. To add these reports to your site, you must add the plugin to the reporting element in the POM. If you have included appropriate menu ref equal reports tag in your site descriptor, then you can generate the site. Those items will appear in the menu called project reports. Not many reports plugins provide a parameter called output directory to or similar to specify destination for the report outputs. This parameter is only relevant if the report plugin is run standalone, that is by invoking directly from the command line. In contrast, when reports are generated as part of the site, the configuration of the Maven site plugin will determine the effective output directory to ensure that all reports end up in a common location. As an exception example, we can consider this. Here fails to execute goal, etc. And this is artifact resolution exception, unable to locate site descriptor, could not transfer artifact parent project XML site _en colon 1.0.141.1 from to Eclipse and etc. As an error example, we can consider this error occurred in the environment with Maven site 3.2 and Java 3.3 and Java 1.8. Warning error injecting. This is a warning also. ogg.apache.maven.report.projectinfo.ci management report javalang.no class found error. org/apache/maven/doxia/ site renderer/ document content. This is end of my presentation. Thank you very much for watching.